Smartphones are revolutionizing field operations.
Send out the truck drivers, the geospatial experts, the front loader drivers.
These are big numbers, even if you're taking 10% or 50% off them.
Trained hundreds of people already, but one thing I've noticed for sure, it's very evident.
Evolution in the last 5 years with the acceleration of the phones.
You've got one piece of equipment. Where do you send it to?
What's the condition of that asset at any given time?
How much expertise and training does it require?
Well, a piece of the engine that was found in a field.
You need special permission, you need special safety training.
To solve problems that were traditionally unsolvable.
Awesome. Welcome to RealityCapture Network webinar here. We've got several great experts with us today, and we'll be talking about how smartphones are revolutionizing field operations. So we've got a really great presentation, really great conversations to happen here, and we'll be diving into the technical side and how iPhones, smartphones as a whole with the LiDAR capture present a whole new opportunity and a whole new variety of solutions that were never available before. So without further ado, let's start jumping into things. So I'm your host, James Mosimann. I work here with RealityCapture Network. My background is in laser scanning, scan-to-BIM, and sales primarily. But real stars of the show here, some of our experts who have worked in the mobile implementation and mobile success. So first expert, I'd like to introduce Nathan Pugh. Nathan, if you'd like to introduce yourself, please go right ahead.
Hey there, Nathan Pugh. I'm the CTO of VTS, and I've been with VTS kind of part-time, full-time for about 2.5 years. Prior to that, I was with Trimble for 21 years and AWS for 3 years. My background's all in geomatics engineering from the days when people couldn't spell GPS, so got a pretty early start on things in the positioning industry and geospatial industry.
Awesome. Thank you, Nathan. Welcome. We're honored to have you here. And let's jump to our next expert, David Boardman. Take it away.
Yeah, my name is David. I'm the founder of EveryPoint. I've been working towards the vision of digitizing every point on the planet every second of every day now for about 13 years. And we're slowly progressing towards making that a reality as an industry. And I'm excited to continue to advance that vision forward. I'm here today talking about Stockpile reports and particular how to use smartphones to solve problems that were traditionally unsolvable just because of the scale of the problem, the geographic distance it required to solve the problem. Lots of factors we'll jump into. So looking forward to the conversation.
Awesome. Looking forward to it here. And last but not least, Eugene, if you'd like to introduce yourself as well in the forensics, please go ahead.
Yeah, sure. Eugene Liscio here, and my background it was in engineering. So I started out in the aerospace engineering world and obviously made a career change, and I got into forensics around 2005. And most of what I've been doing since then is trying to solve problems using 3D technologies and applying them to different things like bloodstain pattern analysis, shooting reconstruction, suspect height analysis, integrating 3D with just a number of different things. I teach at the University of Toronto in their forensic science program. And then a couple of years ago, because I had all this time on my hands, I said, hey, I'll start an app, a forensic app business. And so Recon 3D started in May of 2022, and it's been a wonderful ride since then. So I got my hands in a few places, but a lot of exciting things happening. And thank you for the invitation to speak here today.
Awesome. I'm very happy to have you here. And excited to jump into things. And I'm super excited to dive into this whole conversation because relative to what a lot of people are doing in laser scanning and just, maybe AEC, this expands so much broader than the applications of standard AEC. We're talking about so many different industries and the solutions that are available to a much broader audience for things that were never possible, and that really brings us to, what reality capture is opening as a whole. And in classic reality capture technology, the conversation is, it very often comes to what's the right tool for the job, what's the right solution, and that can often be simplified to a speed versus accuracy, and you're somewhere on that paradigm. You want a fast instrument that's relatively low accuracy, or do you want the slower instrument that's going to be your accuracy instrument. And this is a little bit different. The conversation here is a little different because we're not just talking, about iPhones in the pure technical standpoint of looking at one iPhone and measuring that against, what you're comparing against your specialty equipment. All of that necessary, your high accuracy special equipment, right tool for the right job very often. But here, the solutions that you gentlemen bring to this table, they change the conversation a little bit. It's not so much what is just the right technical tool for the job. You really are presenting a whole new solution, by broadening a lot of that. So I'll come here to some of the new factors, that we've discussed and that you've introduced. And Nathan, why don't you talk first about, how the iPhone opens up a whole new opportunity of solutions rather than the traditional speed and accuracy conversation that we see.
I think one of the big factors into it is there's a price point for investment in new technologies. And the area that we're involved in with critical infrastructure, there are so many assets to be measured, to be captured. And a lot of that is asset health. What's the condition of that asset at any given time? And what's the current state of it? And the fact is that the affordability of the technology, things like AEC and mining and some of these bigger industries, oil and gas, could invest into it. But now I kind of look at this as the next generation of GIS data capture, where the units that they were using for GIS data capture, feature and attribute, update, and collection were always a little bit lower priced. So now to me, this is bringing the capability to have 3D to that industry, where it wasn't really accessible before because of the price point.
Awesome. I think you're spot on. I think that you are absolutely spot on with that. And, in addition to that, we're obviously looking, the time of capture, and not just the time in your conventional speed per se, but time in a new, about being there when it's important. So David, if you could chime in just a little bit about how that really impacts your industry and stockpiles.
Yeah, so I like to look at the problems that, you can solve with state of the Walmart versus state of the art. Right. So like, as Nathan said, as reality capture came to the market, it was very expensive technologies. And the industry was looking for, well, what problems can you solve that someone will actually value the data enough to write a big check to pay for these big expensive solutions? So you see a lot of the roots, in the reality capture industry in those very high-end use cases, high dollar, stakes, and very accurate technology required. And that was a great starting line, but I've always been saying, well, what can you do with the phone that's in your pocket, right? And I've been looking at this my whole career, right? From, how do you get away from the PC on your desk, right, to the phone in your hand, right? How do you go away from the DSLR camera to the camera that's in your pocket? How do you go away from the big aerial mapping airplane to a little drone that's flying over? Right. So you always see that evolution of going to those lower cost technologies, and the technology's catching up with those more expensive ones. But as you look at that, you're looking for new problems to solve, right? Because you have different economics to bring to the table, and you have different usability. How much expertise and training does it require, right? So I really started looking for, what are those historically unsolvable problems that you can now solve? And, 12, 13 years ago, when I was walking around with an iPhone 4 trying to figure out what to do, right? Looking at all these different problems, came across this problem of how do you do an inventory count of bulk materials? It sounds trivial, and it is trivial if you're hired to go do one location with 8 or 10 piles. But I like to use the DOT's examples. All these states around the US, they have hundreds, if not thousands, sometimes tens of thousands of piles across huge geographies. Right? Most of these states had never done a full statewide inventory count before because it was just an unsolvable problem. You couldn't imagine how you could use accurate sensing technology with skilled resources to cover that large of a geography. So now looking at, well, how can you use the device that's in everybody's pocket, palm, or purse and send out the whole workforce, send out the truck drivers, the front loader drivers, the geospatial experts, the bookkeepers, the CFOs, send them all out to capture all that information to do an inventory count, right? So I think it's been an exciting chapter of evolution in the last, especially 5 years, with the acceleration of the phones and the reality capture technologies that the big guys are giving us to work with, from those active sensors on the phones to some of the AR core and AR kit capabilities. So yeah, we're just hitting that wave to where we can solve historically unsolvable problems. As boring as how do you quantify your piles of rock across massive geographies?
Yeah, but very important stuff. And like you're saying, spread across such a huge geography that, that timeliness and being there is something that, wasn't really possible in the same way before. You're talking about huge quantities of assets. And that sort of brings us here to the accessibility of those assets. So Eugene, if you'd like to chime in a little bit just on, the access, and the access with the iPhone as well.
Yeah, definitely. One of the issues in the forensics area is that, well, and you all said it already, the equipment is rather expensive. And if you have a large department where you've got, 10, 15, even 6 or 7 people in their forensics group, well, you have a limit because they typically only have one laser scanner. There are very few agencies that are going to have, 10 or 15 scanners. That's just not, they exist, but they're very rare, very rare. So the issue becomes, well, we've got something that happens on midnight, or there could be 2 or 3 things happening at once, and then you've got one piece of equipment. Where do you send it to? Is it in use already? Do you ship it back? Do you pull it from where it is? Are people rushing to do things or whatever? So I think most agencies that I'm dealing with, they get it right away. It's a phone, it's in your pocket. It means that the people who are, responding to this call or whatever it might be are ready to go. They don't need to call to get the equipment there, to get the big truck. They can start documenting immediately. And thinking even bigger, I mean, not just the forensics people, but think about how accessible, with many departments now, video is. Like, so for example, the body camera, right? The police have them right away. Mm-hmm. And so they're recording their interactions with the public right away. And I've always said that one of my goals is to turn, Recon 3D into, something similar to what Axon is doing with body cameras, is just bringing it so that everybody has it. You're not going to miss the opportunity. And so the fact that it is just a phone and, it's readily available, it's not a heavy investment. They already issue phones to their, departments and things like that. Mm-hmm. It's just a matter of, getting the iPhone with LiDAR, which is a little bit of an upgrade, but it's not a major, gap that can't be overcome. You're seeing a lot more people. And if I could just chime in on the gateway for a second, I don't want to go over time here, but
absolutely,
just sort of an anecdote, but the thing that I've seen a lot of is I have this course on the Recon 3D class. And so, we've trained hundreds of people already. But one thing I've noticed for sure, it's very evident, is we are getting a lot of brand new people, like brand new, zero 3D experience, nothing. Some people are, older people that maybe, were dealing with a roller wheel and a tape measure. And, the fact that we're getting these brand new people. I had one class where 60% of the people, I did a little survey, were brand new. So starting from zero. And the fact that this is a gateway to getting into the whole 3D realm just opens up so many doors for people. And so to me, that's exciting. That's really exciting, seeing that we're introducing this to a lot of new people. And I know already it's had an impact in the area. So yeah, I'm pretty excited about that.
Yeah.
I love that. I love that.
Absolutely. It's super exciting. And I'm really excited to see, we're talking here about it, how it's changing things, but you gentlemen are the ones who have, been implementing it and getting some of those successes.
James, just before we move on here,
sure.
We kind of have this theme around what the three of us are doing that we've termed crew sourcing, which is a play on the words from crowdsourcing. But one of the big differences here is that in crowdsourcing, you just going out and collect data for you and being that data collection mechanism and the sources of data. And in most of the applications that we're talking about here is the general public doesn't have access to these areas, right? Like you don't want the general public going and filming crime scenes, right?
Right.
And it could be manufacturing facilities or, critical infrastructure, substations and things like that. So people generally need to have training. They need to have safety courses. They need to have all these other kind of certifications just to get into that area. So that accessibility piece is like who's on site already that has those things. Because for the services part of our business, we have to go and get all of those safety certifications and whatever other could be being accompanied by staff from the organization that we're capturing for, or those type of things. So the accessibility, when you've got people there already, why not use them to do the data capture?
Yeah, I think that's perfect. I think that's perfectly said. Well, Nathan, let's just jump right into how some of your team is doing that right now, with the access that they have to, your sites and your utilities and things. Tell us a little bit about, your successes.
Yeah, we've chosen to focus on the critical infrastructure, and that could be, power generation and the energy side of things, but also the telecommunications and broadband. And you just look at the amount of money that's been put into and earmarked for infrastructure improvement projects and new infrastructure. And like these are big numbers. Even if you're taking 10% or 50% off of them, they're still gigantic numbers, right? And I think one of the precursors, or I'm kind of saying that's the tip of the spear, is that having high-speed communications. There's the broadband initiatives to move to get wired broadband, high-speed wired broadband out to rural areas. But that communication then opens up the fact that you can now build schools and hospitals and other services and other infrastructure pieces out in those areas because of that communication side of things. So I see the broadband initiatives as being critical. If we go to the next slide, we've got the number of assets that exist. So if you're entirely greenfield, like it's fine, you can kind of go build in a vacuum. But in most cases, it's a brown field where you're adding on. It's like, what are the existing capabilities? What can we use here right now? We've got utility poles. What's on them now? And then you need to know what we have now before you can start designing anything new, right? And then when you look at these industry and critical infrastructure, the number of assets that are in play, like 180 million utility poles and 400,000 estimated cell towers. And for anything that gets updated, you need to know what exists before you go out to the site. So, we're taking an order of magnitude, maybe multiple orders of magnitude of the things that we're measuring before. And like David said, it's not just measuring one or two piles of gravel or sand. It's measuring tens of thousands or hundreds of thousands of these things. And I think if you look at like traditionally the surveying and 3D capture and reality capture industries have always struggled just having enough people to fill the existing roles that they have. So now we're massively exploding the number of assets that we need to capture, but we still are working with the same number of people that we had and a lessening number of people that have the expertise in those industries. If we go to the next one, basically I'll talk through three different use cases that we're looking at with VTS and the VTS 360 capture app. So one of the things that I mentioned on the accessibility is getting people to site, having them know what to capture, scripting, and making sure what they capture is actually usable. And so I see the problem that we're trying to solve is making sure that the right information gets to the right people in the field. They can accurately capture everything they need to be able to bring that back to the office, and then it goes into downstream systems. So we've been working in the telecommunications industry. Obviously, this is a cell tower rooftop, and with towers, we use drones to capture those. But with 5G, the rollout of it is that more and more of those are going into urban areas and their line of sight. So they need to be on rooftops, and you generally can't fly drones, and you can't get permission to fly drones in those urban areas, downtown corridors, etc. So our kind of mandate here is like a drone and the phone, and we can capture everything possible, merge them together. And as soon as you need to go indoors to capture a ground compound or an office area, the drone's not very useful either. So one of the things in the telecoms industry is that the site owners are generally not the people that own the assets. And so you'd have a rooftop that might have 3 different sets of antenna array and RF equipment, and and different types of telecom equipment on it. And so they don't, when you say a T-Mobile goes to upgrade all their stuff, they don't know what the owners have already put on there until they go. And so they can't do their RF design, they can't do their antenna array design and all the other things they need to do until they know what's on site. And so with, and the drive for mobile broadband and increased amounts of data by the consumers is just getting more and more. So it's a big race to get, high-speed networks rolled out as quick as possible. And every time they do that at every site, they need to know what's on site before they can start designing. If we go to our next example is, virtual access to confined spaces. Really what we're talking about is kind of like underground utility chambers, manholes, underground structures, things that generally, if you've ever been at and had your lanes go down to one because you've got someone basically doing manhole work or electrical utility work, they traditionally need to have 4 people because you've got confined space entry, you need special permission, you need special safety training. And we're looking at being able to do that just we've kind of rigged up lighting kits and using an iPhone or iPad to very quickly and safely capture what's going on underneath in these utility chambers. So that's another big area where it's just been time consuming. In the past, people have been putting, $40,000, $50,000 scanners upside down. And when those drop into a manhole, they generally probably don't survive very well. So we feel like this is a very kind of quick and easy solution to replace what people have been doing, which has been challenging in the past. So we can reduce that four-person crew down to 1 person, likely 1 or 2 people, and it just makes it easier to capture. The last use case that we've been looking at, and very kind of similar to the the cell phone towers and cell phone arrays, is utility poles. And the utility poles they don't just necessarily have power, but they have wireless communications, they have broadband communications, they have fiber, they have all these things that are basically going through the wires and the cables themselves. And it's the same situation where it's, hey, we want to run wired broadband through these areas, but we have no idea what the capabilities, what the existing assets, and what the capacity for putting new transmitters, whatever it might be, in those areas. So working with, and this has been an area because there's so many of these that's been it's been very difficult to get technology into the space. So currently they're using roller wheels and some measuring sticks and scale sticks and things like that. But we believe in this sector is that a mobile scanner, and then with the mobile scanner, maybe you get 80 to 90% of the coverage and the mapping that you would like. But you still have these back lots, and you probably have the 10% that need to be walked and collected. So we're looking at, hey, if we can use this quickly and easily, get a 3D point cloud of this asset. And then really what you want is, as we see in the video, you have these takeoffs on, what are the elevations of all the connections, what's the span, the height at the mid span, and some of these other pieces of information that get extracted automatically from that. So those are the big things that we're looking at from a VTS 360 capture side of things, where we think the volume of these and the people that are out there, whether it's technicians doing maintenance or walking the lines looking for safety issues, that could basically go and crew source that information for these specific industries and utilities.
Awesome. Thank you, Nathan, for chiming in on that. We're getting some questions coming in, which we'll answer a little bit as we go, and we'll have more Q&A here at the end. But with one of our questions, just to answer it briefly now, it was asked if this type of work puts your traditional scanning in a different place, or if it destroys any trust in companies that do more of your traditioning and survey work. But Nathan, I think you're hitting really well on this point of, it's crew sourcing. It's not, these are not applications where you need your high accuracy, you need your traditional survey. You're capturing something where you would otherwise have nothing for your assets, where there's so many people playing, and it's a step up from your camera, but it's not the specialty use where you would need a scanner. Do you want to chime in on that a little more?
Yeah, it's one of the things I remember commenting on a thread similar to this on LinkedIn one time, is that, as a measurement professional, you want to be able to have confidence in whatever tool you're using that has the accuracy that you require for that specific application. And and I think there's ways using scale bars or using ground control or using other things that can be scripted into the workflow that then allows you to have some idea of like, okay, here's what I can rely on, and here's my confidence in this measurement, this data collection. And there's some different ways to do that. But hey, if I need a distance between two poles that's within a foot and that's good enough, then I might not need some of those other consistency checks or other redundancy checks to be in place. So I think it's always knowing what the application is, what the requirement is. I'm probably not going to use this to fabricate pipe for an internal processing plant. But it could be used for, rough takeoffs for quantities, or for, hey, will it fit? Can I actually fit something through this door? And those type of analyses.
Yeah, I think that's perfect. And, just with my scan-to-dim experience, I know that using an iPhone for process piping would be a poor choice. It would, it would be, you'd have some issues. But, these are the kind of industries, like you said, for maybe quantifying things. And David, I think that takes us right to you. We can start talking a little bit about how, this technology is really used widely in your stockpile analysis. So please take it away.
Yeah, and I'd love to jump in on what Nathan was saying there before I go there. This whole conversation feels very familiar. Been around a while, and remember when mobile phones were first becoming a common thing that your average person could have. There were some early discussions about, should we put a camera on a cell phone, right? And at the time it was, well, that's a ridiculous idea because it'll never be good enough. The quality of a cell phone camera will never be good enough, and people will always have their pocket cameras or their DSLRs. And there was even a time when professional photographers, right, would be almost like, well, that's a toy, and you need a professional photographer to come and capture this event because those are just toys, right? And so as Nathan was responding, and the question comes, like, I'm having flashbacks to these conversations about saying, no, cameras will never succeed on cell phones, right? And I would imagine there's probably a lot of parallels there we can all draw to how that transformed, and how we had very high-end cameras that were used by professionals that I'm sure to do things in forensics that Eugene could tell stories about, that I'm sure people in the entertainment industry could talk about making movies and commercials, right, that are all now done with cameras on cell phones. So I love that conversation because I think it is a painful transition of going from a very limited few people with very specific technology to suddenly something available to a much larger audience with much greater availability. So speaking of which, the problem that I'm sharing and talking about, it's just another asset. Nathan's done a wonderful job talking about how there's so many assets out there that we all need to understand. Sometimes we just need to understand, is the asset there or not? Sometimes we need to know, what's the condition of that asset? Is it increasing in size? Is it decreasing in size? What's the value of that asset, right? And I've been deep in this problem for a decade now, right? Working with lots of very large organizations who have these real problems to solve. And historically, they haven't been solvable because you needed the highly trained individual with the very expensive piece of equipment to use. And the example I just threw up this map here. These are road maintenance organizations, right? And these are just, piles across these road maintenance organizations. And they have problems just like everyone else. Especially, I'm sure everyone on this phone call sees a pile like this and goes, that's a pile of cash. That's $60,000. That's $120,000, right? Your average person walking down the street sees a pile like this and doesn't put any value on it, right? But you got to know, if you're in the business of moving, selling, consuming bulk materials, you got to know what you got, right? What's the value of it? What inventory do I have? I need to update my balance sheet at the end of the quarter to talk to Wall Street. What do I communicate as my inventories, right? And historically, it was just unsolvable. So everybody would have little sampling techniques, or let's do rolling counts, right? Or different methods to say, I'm going to go count all the piles across the state of Wyoming. I'm going to go count all the piles across the state of Alaska, the state of Texas, right? And it is just an unsolvable problem. So now, thanks, starting on the iPhone 4 all the way now to the iPhone 15, right? Folks can go out that are on staff, that are a front loader driver, a maintenance shed manager, a scale house operator, and they can participate in a statewide count. So again, it's a crew source problem. I love that word, Nathan, that VTS has come up with, crew sourced. I use it all the time, right? Because these are individuals that have been provided an application on a phone. Many times they're provided the phone, so they make sure it has a certain level of technology. And usually they've been provided some level of training, which could just be, hey, my coworker showed me, or it could be a video they put up on their corporate website, or they send out an email blast, or it could just be that they watch YouTube videos and figure it out, right? So now you've got, many states across the United States that don't even blink at this problem, right? And I love the example of, hey, we got 12,000 stockpiles that we need to go figure the value of next week for end of quarter across 248,000 square miles, and nobody even breathes hard, right? I mean, that's a decade of, technology development, and it's also a commitment to very large organization to establish that crew sourcing model. But now, it was an unsolvable problem that now people don't even think twice about. And I love, that challenge. So the solution, next slide, like I said, is crew sourcing. Are these geospatial professionals? No, one of them might be, right? But most of them are just average, everyday employees and workers. Well, actually, one of them is our chief scientist, so that's not fair. One of them's a PhD in computer vision. But there's some other people in there that, are just DOT employees or average people that can now do this job that historically, Nathan, I love the way you said it. I mean, there's more and more assets to understand every single day. And the number of geospatial professionals or reality capture professionals is not scaling fast enough to possibly reach all the assets that people need to understand. Do they exist? What's their condition? What's their value? So anybody can try SR Measure. If you haven't heard of it yet, you can go to the App Store, iPhone 12 or newer, download and try it. You can measure once a day for free. Anybody can. There's people doing it from Malaysia to Fiji to Australia to every state in the United States. It's crazy how many people can now go get an accurate and precise measurement. So happy to talk more. I'd rather make it more interactive, have you ask us some questions, but that's just a high level view of what we do.
Yeah, I think that's perfect. I think you laid that out perfectly, David, describing how, especially with this map here, you have such a huge quantity of assets. And like you're saying, anybody walking around sees the stockpile, sees the gravel, and that's money, and for the people who own those assets, that's hard to quantify. And sending special trained labor and equipment out to a high number of sites like this, you're talking exorbitant costs, huge costs that are preventative of doing this sort of work to actually maintain these assets in a profitable manner. The cost of these assets would just increase exponentially if you had to employ specialty labor to measure them every single time. But again, it comes down to what's the right tool for the job. And for simple tools and simple jobs, you can start leveraging the really, really simple equipment, and you can do it simply. You can get people to adopt it easily. And, it's widespread. Like you can have somebody who operates a front loader moving gravel now collect data on your stockpile and say, look, here's how many cubic yards we have of all of these different piles. And that, that's a simple application that would be a low cost job or, not worthwhile for people who do the specialty work. And those are absolutely necessary jobs and trades specialty, your terrestrial scanners, your SLAM-based scanners, and all of those trades, they're very necessary. But Stockpiles is perfect industry where it's like probably not a lot of people doing this every day with your terrestrial scanners because it just doesn't make sense people will pay for it. But there's so much value in those assets. I think you nailed it.
Right. Well, and that's, I think with the limited resources that we have, and I'm sure there's many on this webinar, right? There's a lot more high value problems to be solved that require expertise and require, again, those high-end tools, high-end trained individuals. Then my goodness, you don't want those resources wasted running around measuring piles of material, right? And that's, we've seen in many DOTs, many construction companies, for a while, the geospatial teams were excited to buy drones and excited to use drones to do it. And then after about a couple of years, they're like, you know what? I'm tired of getting called out to fly this drone to measure this pile. I'd rather be over working on this advanced, engineering project where we're doing true survey work with boundary lines and trying to make good decisions about how to get a bridge to come together, right? So really using their skills and tools on the higher value problems and not getting distracted by having to run out and do this annoying problem that they'd rather just outsource. So maybe think of it as back in the day, I imagine that the Vanderbilts had to hire a fancy photographer to take pictures of their kid's birthday party, right? And now we can all just do it by pulling a phone out of our pocket and snapping a picture. So I kind of see we're going through that evolution of those professionals with high-end technology can start to stop doing birthday parties and start focusing on making art and major films.
Awesome. I think that's perfectly said. Well, let's jump into, and let's look a little more. Eugene, you can take over and talk a little more about the technical piece here with the iPhone. I know that's a lot of your expertise. You've done a lot of research in forensics. That always begs the question too of, when you hear about it, how technical, how accurate is a lot of this. So if you could chat a little bit about that and your research experience applications here.
Yeah, for sure. I'll lead into that for sure. I wanted to sort of talk about, what's happening today in the forensic world. And, for sure, one of the things that is occurring is that there are plenty of scanners out there that many agencies have, but they typically have one. So when you have a small police agency, even if you think about it, even a large police agency like here in Toronto, we got millions of people in the city and there's only 2 scanners. So there's stuff happens here. It's getting busier and busier. And so it could be that, both are out at one point. And so you have a problem. If you think about something like a sheriff's office that has a very large county to deal with, I've seen this before. Something happens at, some place in the county while the scanner's 2 hours away. So they got to drive it down. And so there's all these, things like this, which are inconveniences that are solvable by having, the iPhone in your back pocket. And so I think that's where it's really, really helpful. Of course, cost is an issue. These are, expensive pieces of equipment. They're fantastic at what they do. And I always, ask people to keep things in perspective that, we're using a phone app and you're using a $70,000 piece of equipment. And so, they each have to fit in their places and they do certain things better in some cases on the low end of the scale and on the high end of the scale. So there's other factors like, the costs of the scanners, the maintenance, the calibration, sending it back and keeping people trained. It's a big deal because people rotate in and out of a department or they leave and then all of a sudden it's like, well, nobody knows how to use the scanner or we only have one person left who knows how to use it. So there's a number of different factors there. Next slide. So, if you think about the potential change and the paradigm shift that could happen is what if, the first responders, the people who are on patrol or paramedics or whoever, just think about it. If it's in their phone already, they can quickly capture what is there. So, if there's a body on the ground or something that has to be moved immediately, that can be captured. If there's rapidly deteriorating evidence, it's snowing, it's raining and things like that, you can capture it right away. And the great thing is, it integrates well with what people have already. So if you have a laser scanner, if you're using photogrammetry, if you're using these other technologies, it's not a, this or that, they both can work together. And so having that evidence preserved can be super helpful later on down the road. It's just something that would be a lost opportunity elsewhere. And so, the cost is not significant, I believe. I know that, having said that, one of my biggest challenges is, people are Android users or they don't have the right kind of phone, that is not LiDAR enabled. But if you look at the gap between, a mobile phone technology and what the app would cost or something, and then what the next step up is, it's significant. Okay, there's no sort of little step, a few little steps. There's a big wide gap there. So yeah, it's what I'm seeing is that it's super beneficial, and I could give many examples, but let's lead into the technology here. We can go on the next slide. So we've been talking about these iPhones, and I don't know, many of the people who are listening in, you may or may not be familiar with it, but it's this little circle that's just sitting there on the back of the camera. So that little guy down there, and this is on any of the Pro or Pro Max models since the iPhone 12 and the iPad Pro since 2020, I believe. So it doesn't look like much, but there's a lot of interesting technology that is sitting there. And what do you get? I won't get into what the device looks like, but let's look at what the LiDAR looks like, what the pattern looks like, and we can play this video here. And is it playing? Hopefully it'll play. If not, it does. Oh, I think I just used an image here. But what you have is this grid, and you can see the phone and the iPad Pro, and they're actually very similar. There's some little dots that you're seeing on the iPad Pro, but that just has to do with the exposure and the way that it's moving. But it's a shifting pattern. So on the older, the 12 through 14, it's a 12 by 12 grid of dots, and it shifts and it moves. And as it moves really quick, it makes a larger overall pattern. So it's a really cool way of sort of maximizing the power, how much power you can put out there and getting a larger pattern overall. And there's other things that they're doing with this particular pattern, but if you can imagine that you can know the distance to each of those points, then you can do things with it. So I have to go to the next slide. A depth map is something that is used in computer vision for a number of different things. But if we look at this hotel room here and you see this little yellow dot, what if you know that is, I don't know, it's 3 meters, it's 10 feet away or something like that. And what you do is, if you were to take that pixel or that distance and then convert it into a color representation of the distance, you would end up with a color depth map. And so having that is super useful. So the LiDAR sensor does a couple of things. If you have an image frame, like from your video camera, and you pull one of those frames out, normally with photogrammetry, you just have a video frame and there's not a lot of information that is associated with it. But now if you have this depth map and the reference frame or whatever it is you're pulling, you have information about what is inside of that image, which is super helpful. So for two reasons. One is, first off, you get scale. So if you're using photogrammetry has no scale. You have to give it some information, whether it's through GPS, whether it's through reference measurements, control points, or whatever. If you just took an image and there was nothing inside the image, and especially with video, because video doesn't have EXIF or metadata and all that other information that you get out of it when you snap a regular picture, well, the LiDAR helps with that. The other thing that the LiDAR does is it helps with difficult surfaces. So shiny black surfaces, the ones that everyone cringes at when they're out there, and they've got a scan or something like that. The iPhone LiDAR and the results that we can get out of this thing are particularly robust. They're really impressive on what it does. And so, being able to scan on somewhat difficult surfaces, and having this range of about 5 meters on the sensor, and of course associating some kind of a scale and getting that depth map is really what's happening behind the scenes, and that can be applied to a whole number of different areas. So in my world, if we go to the next slide, there's a number of different things. So just general crime scenes, collision reconstruction, that is a huge one. And in fact, when the app first went out, there were a whole bunch of people that jumped on this right away. And they saw, an opportunity to have this little scanner in their back pocket for, collision cars. They do vehicle inspections after the crash has happened. The vehicle is in a yard or something like that, and they can go scan it. You can do, small sections of roadways, although there is a limit to how big you go on these things. And then, you may be better off to use photogrammetry or whatever. But, in a pinch, you can get these sections of roadways. And for the other two areas that I focus in, I call it B&B. It's not bed and breakfast, but it's blood and bullets. And so, bullet trajectories for sure. Very, very useful to be able to document this accurately, and also bloodstain pattern analysis. And you'll find that, a lot of people that work in these areas don't all have access to a scanner. And so, we've been doing a bit of research in this area. So if we just go to the next slide. These are a couple of just quick examples of things, just showing you some of the detail that you can get. So, a crime scene, a body on the ground, these things like small bedrooms and stuff, that can be super, super useful to pick up a bunch of detail. The fact that it is mobile, it's something you can hold in your hand, also means you can get around those tight spots, vehicle interiors. And so it's relatively quick, because if you need detail and you have a lot of blind spots, you're not just doing one scan with a terrestrial laser scanner. You've got to move it, find the right spot, move it, find the right spot. And so the time starts to compound on a terrestrial laser scanner, where, something like this took me like, 60 seconds of documentation time, right? Really, really low, really, really quick. Next example. So, vehicle damage. Again, we're talking about something like this. On a bad day, I can do a vehicle scan in about 100 seconds. Okay, so if it's just a passenger vehicle, the time is very, very hard to beat. And, we're getting good color out of this thing, a good RGB point cloud. And so it can be very, very beneficial. And I'll do the next one here. And this airplane here. So an aircraft crash. Now, is this an image or is this play? I wonder if this is going to play.
This is also just an image.
Yeah. Okay. So one of the reasons I wanted to put this one here is getting back to my point about how well this can integrate with other technologies and sort of maximizing the efficiency. So if you have, this is a small aircraft, but let's assume that you have a large scale aircraft crash, and you now have parts that are spread out over, thousands of feet, hundreds of meters, whatever it might be. With a small mapping system like a GNSS system and, your phone, you could go, map out a piece of the engine that was found in a field, and you scan that, very quickly over 60 seconds. You take a few control points. Now I can walk 1,000 feet that way and go map out something else in detail. So I'm picking up the most important points of what I need and still gathering all the detail, using the iPhone app, which is really useful. Now, we could have a long discussion on accuracy, and if you don't mind jumping to the next slide, this is a something that I've done over and over, and other people have done over and over, where we're comparing vehicles. And so this is just an exemplar vehicle. You scan it with a terrestrial laser scanner like a Leica, a Faro, a Regal, or whatever, and then do it with the app, with the iPhone app, and then, run it through here. So this one was done with Recon 3D. And then what I do is I do an analysis inside of Cloud Compare. And if you just hit it again, it should pop up another image. Okay, so this shows you a kind of analysis where it compares the exemplar to what the phone is giving you. Okay, so like the Faro to the phone. And this is a very, very common layout when it comes to the errors. And you'll see that the majority of points fall around the 2 millimeter mark. Okay, this is very common. And 2 millimeters is about 80 thousandths of an inch for those of you working in freedom units. And if you look at the 1 centimeter mark, that's like 0.4 inches or something like that. We're at about 73.5. And then as you go up to about 2 centimeters, you're at about 88, getting close to 90%. And then there's some fluctuation in there. But when 90% of your points are falling below 2 centimeters, that's not bad. I mean, if you think about what you're getting and how quickly you can get it and the cost of what you're getting it at, there are a lot of problems that can be solved with this level of accuracy. Okay. And again, without getting into a long conversation about accuracy, I know that I started with a terrestrial laser scanner, and we had, we argue specs and we talk about how accurate we can get and all this other stuff. And then we go map a collision scene, and if it was within a few inches, nobody cares. You know what I mean? Like it's not that bad because we just want to know where the car was relative to the pole and to other things. So it's a complicated discussion to have because there are factors, many variables that can influence accuracy. But I think the bottom line is, what kind of problems can be solved with this level of accuracy? And there are many. So go to the next slide. There are a number of studies that we've published on the website, and so there's a little QR code if you want to see, but we're looking at very specific applications, like things like I talked about the bullet trajectory documentation and bloodstain pattern analysis, and the accuracy of the iPhone is really impressive. I have to say that sometimes I'm like, wow, I can't believe it was really that good, under controlled conditions. And so I think going forward, if we see improvements in the algorithms that are there processing this data, if the LiDAR sensor becomes improved, right? As we get these incremental improvements over time, we may see benefits here that will get to a point where we are getting accuracies that are very close to what the terrestrial laser scanner will be giving us. So I'm enthused about what we currently have, and I think we have definitely hit the threshold because I work privately, and on the private side, I've been looking for years, and I've known David for some time now, and we've been talking about photogrammetry and all these other things, and but every time I've tried something, it just kind of fell short of the threshold. But part of the reason why I'm here and why Recon 3D exists is because we have hit that threshold, and I think it's just going to get better from here.
Awesome. Well, thank you, Eugene. I think that's perfect, especially here talking about some of the accuracy bits at the end. When we started talking about this technology, that was certainly my first thought: is it good enough? Is the iPhone good enough? I mean, especially in forensics, I think, okay, can an iPhone hold up in litigation? Can it? Does it? How often does that get pressed? Like, oh, it's not that good. It is that good, or something. And the fact that you're able to leverage this. And and it stands in a courtroom, and that's impressive. That's beyond impressive. I think that's a very strong statement, as strong as you can make, almost.
Yeah, I think there's some good. Actually, there's a couple of questions I saw in the Q&A that will relate exactly to that comment you just made, James, about using it in the courtroom and how people perceive using the phone in a professional manner. So yeah, I'll leave it at that for now.
Sure. Well, awesome. Well, that's great. Well, that wraps up our big main discussion. So thank all you gentlemen. We have a few minutes here and a couple questions that have come in that I'll read out and we can address. First, I guess on the topics of forensics and things, Eugene, we got a question of how do you interact and view Recon 3D files or a civilian viewer access? So be specific to yours if you'd like to answer that.
Right. So the app is really about generating a point cloud. And so you can, view it right on the phone. But the idea is to do something with it, whether you're using existing software, so if you're on the crash side or collision side, there are programs like, PC Crash, Analyzer Pro, there's a whole bunch of these different software packages. You take a scan file, like an E57 file, they walk right in, they import right in, and then all of a sudden you start doing your work. So there's no conversions and stuff like that. That may happen internally to the software, but there is that. On the crime side, Leica has Map 360, Faro has Faro Zone 3D. If you're using other software like AutoCAD or Rhino, I mean, that whole workflow is just so simple now. I remember back in the day, you had to make conversions, you had to jump through hoops to get the thing to work in software, but not today. Today it goes right in, and then you work with it, you apply it, you do things with it. So including Cloud Compare, free software, right? So you download it and you take measurements, you can do animations, you can do analysis. I mean, it's incredible what you can do for very low cost these days. So a lot of opportunities for visualization and for analysis and for viewing.
Awesome. Quick. And on the app topic, we just got another question. What was the name of the app for Stockpile volumes?
SR Measure.
I'll type that right in there as well. Awesome. Oh, this is great. We're getting more and more questions coming through, so we'll keep answering some of these until we hit the top of the hour. Anybody else who asks, feel free to ask and chime away. I mean, we've got some of the best minds here in all of this. What opportunities do you see in using Apple Vision Pro headset for reality capture or in other AR, VR headsets?
I know who's going to answer this one.
Dave. Yeah.
Apple Vision Pro. Yeah, so we've experimented with it. To me, it's a wearable. Whether you strap it onto your face or you pin it on your collar, it's, what's the role of these wearables in reality capture? Now, Apple Vision Pro comes with a lot of AR kit, benefits that we can leverage. And because of the privacy model, there's certain things that they won't let us get into. But I have a feeling there's going to be more and more creative ways to get to some of that spatial data that we can leverage. So, I don't get hung up on the device. I think all these different sensors, whether they're strapping them to our faces or putting them on the hoods of our car or the dash of our car or putting a pin on our shirt, they're all going to be participating in capture. So like Eugene said, is people are running at the fire, they're running at the crime scene, they're running at the crash, and the data is just being captured passively, right? That's the future, right? There's probably still this time where people will be pulling devices out and doing it, but I absolutely believe that wearables, whether it's Vision Pro or something people clip on, are going to be absolutely present and a critical part of reality capture in the future. Awesome. And the reason they're laughing at me is we measured a Stockpile with Apple Vision Pro, put it on social media, and we've had 4.5 million views of the thing. And wherever we go, if people recognize us as, hey, you're the folks who measured the pile with the Apple Vision Pro. Even we were at an Apple store in Nashville a while ago, and people recognized us when we walked in. It's crazy how much attention measuring a pile of rock with the Apple Vision Pro brought our way.
Yeah, that's awesome. That is definitely, the initial release of that Apple Vision Pro, it was eye candy for everybody, and it was so hot, on social pages. But it's good. It brings a lot of awareness to technology like this. That's an awesome use case for
yeah, I'll make one comment on that. They say, drones were the benefit of the cell phone wars, right? Drones became affordable and great because they leveraged all the components in your mobile phone, right? And reality capture is the same thing, right? As these high-end VR headsets are pushed by Apple, and as AR kit is pushed into the devices to be able to put a dancing dinosaur on your dining room table, all those things that billions of dollars in R&D is being surfaced in ways that, ISVs, software developers, innovators like ourselves, we can ride along with that technology innovation. So it's good for all of us, for Apple to invest in Apple Vision Pro.
Awesome. Well, let's talk about, there's another question, a couple more iPhone questions came up. Do you guys see this replacing or complementing the technology to tripod-based scanners?
I can take the first pass at that one. I mean, obviously what we've been kind of talking about, we've all used terrestrial-based scanners, tripod-based scanners. The big thing is that this is another tool, and you're not going to go capture 20,000 square feet of manufacturing facility with an iPhone, right? I mean, you're going to use, SLAM system, or, one of the more mobile type scanners. I think the big thing is when you're talking about the range, right? This is a tool as if you can get close enough to the asset where the range is, within that 5 meter range, that it's a very viable tool for those type of applications. And within the measurement specs that they were talking, and in our studies, it was kind of in the 6 to 15 millimeter range of comparing it to, to high-end terrestrial scanner. And I think the follow-on to that as well is that I think there's another question around like what we'd like to see as improvements as we're combining photogrammetry and the LiDAR sensor in our applications that all three of us are talking about. Photogrammetry's accuracy is based off the amount of megapixels in the camera. That's the limitation. So the more the megapixels go up, the better accuracy we can get. And the LiDAR is based on that distance and the pattern that Eugene showed there. So the marriage between the two, like the longer range we can get and the more megapixels we can get out of it, that's probably the ideal things that in the wish list it can continue to increase, right? Because it just lets us capture from a further distance and maybe capture things that weren't quite as accessible before. But you're never going to have a camera to measure the high wall on a mine from a kilometer away, right? So that's, there's always going to be the place, I think, for these high-end terrestrial laser scanners and the mobile scanners as well, back of a vehicle scanner.
Yeah, whole other webinar. Don't forget AI ML and what's possible there when you throw that in with what you already talked about. Traditional photogrammetry, active sensors, throw in AI ML. It's going to get real interesting real fast.
Yeah. Well, let's answer. We just have a couple more here in the queue. We're hitting our time right now, but let's answer these last couple questions real quick. Thank you all for breaking the iPhone accuracy myth. So I think credit to you, Eugene, especially there. You had a wish list. What would you do with this mobile 3D system to improve?
Well, I think Nathan touched on it, and David too. I mean, the limit is really, whatever the manufacturers of these phones and these devices want to put into them. I mean, if you think about what is in the device and what we're getting out of it, it's pretty amazing what's happening there. But now what happens when, like David is saying, AI, machine learning, and you start getting in these really difficult areas, but, the algorithm or whatever is understanding where there's going to be problems and it can fix it. And not only that, but also the context, right? So when you take photogrammetry, it's just looking at the image for pixels. It's looking at neighboring pixels and things like that. But now when it looks at it, if it says, you know what, that's a glass window. I know it's glass. It's a window. I know it's flat. And now it can say, well, it's flat. I can do some repairs there where you would normally have a mess, but it also can tell you how many windows were in there, or it may be able to tell you like how many trees were there, or maybe to tell you how many vehicles were there. So it's not just about, the quality of the data that we're getting out. It's the context and, all the other stuff that could be coming in the future that, I mean, what can you do now if all of a sudden, I'll just take a little example. Something I've been working on is I take a point cloud and then I run it through a little algorithm, and it can come back and say, well, you know what? You had 5 evidence markers inside of here, and there were so many cartridge cases, and there was a gun, and there was that's pretty incredible when you think about it. When it can start counting and recognizing objects in the point cloud and in the images, I think that's what in the future I'm really looking forward to.
Perfect.
Agreed.
All right. This is another question from the beginning of our conversation, really in framing the whole conversation around speed and accuracy. The question is speed really a function of a dedicated scanner versus the smartphone, or is it more convenience and price versus speed and accuracy? So I think that was a little answered kind of throughout the whole presentation. When we talk about speed, it's not so much the speed of the sensor, so much as the speed of the whole workflow, the whole process. But it's absolutely, maybe could be stated bringing convenience into it. I think that's where you gentlemen each in the added 3 components that we put into it. It's not just looking at sensor speed, sensor accuracy in the traditional sense. So I don't know if anyone else would like to chime in on that piece.
Yeah, I think it's time on asset, right? If we speak it in generic terms, right? How fast can you get in and out and get the data that's needed, and how confidently can you do that? I think of availability, right? I love the old, when they talk about photographers getting in and talk about, what's your favorite camera? It's like the one I have with me. I love that answer, right? Because that availability is important. So to always have it with you when the opportunity presents itself to capture the asset or the scene is so important, right? It's so important to solving a lot of these problems.
Yeah, totally true. And let's wrap up with this last question. I think that this one's really, really crucial, especially for so much of our community and network who are so heavily invested into the specialty technology. And there's some sentiment that it does not appear professional to be paid to scan a construction site using the iPhone. It may destroy any trust in companies that do survey work. Do you feel this headwind? So what's the real risk of this, if there is a risk, and how is that mitigated? And how does this technology, so much we've answered already, but blend and complement those tools? How do we mitigate and navigate that risk of destroying trust in survey and traditional scanning?
Yeah, quick story if I can. So this is like right along something that happened to me and something that I anticipated. So there was it was a court case, a homicide case in the US. I won't go into details, but basically the person working on the case had like some terrestrial laser scanner data and they had to collect some more data. So they used it with Recon 3D. And this was going to trial. And the person that was doing the work said to the attorney, "Oh yeah, I captured the other data with an iPhone app." And the attorney said, "Oh, don't say anything, don't mention anything about that at trial," right? They didn't want to talk about the fact that you use an app.
Right.
And I think the fact that everybody uses their video cameras and these other apps and stuff, it seems like common ground. So there is definitely, I mean, there's definitely something there to it where people think that, oh, maybe it's not a professional piece of equipment, or you can't do good work with the iPhone. And I think you just have to know where it fits and how it fits. But from my side, I mean, I'm doing a lot of work on the accuracy studies, on research, on validation, looking at how we can apply this to many different areas. And I think it's just a matter of time. David said, why would you put a camera in a phone, right? It was a crazy idea. And now, could you imagine somebody making a phone without a camera? No, you can't, right? Right. It doesn't register. You know what I mean? So yeah. I think it's just a matter of time as people start to accept the technology, using it in actual work, and that will soon disappear.
It's also, James, in my view of things, like all three of us have done our own technical kind of due diligence on trying to prove the accuracy and comparing it against other sensors, right? So depending on what that application is, if it's like, high-end AEC applications, you may want the things that we talked about, like ground control and scale rods and things like that in every single scan, right? Because you need to prove to yourself and go back to verify as a check that I'm getting the answers that I think I should be getting out of this, right? But for some applications, if you prove to yourself it works once, then you're probably fine doing it over and over. But for ones where there could be liability concern, you may want those extra steps to make sure that you've got some proof that you're measuring what you think you're measuring.
Yeah, the headwinds are real. I don't want to discount them. They are real, and you must navigate them, right? But I will share that over my career, I've leaned into several headwinds, right? And it's not that long ago when people said Windows would never run in the data center, right? And that Linux software would never be run by corporations, right? I mean, you can just go through technology disruption and change after technology, and the headwinds and the resistance is real, right? And so you have to know that they're there, and you have to know how to navigate them and be prepared. But just know at some point the wind is going to shift, right? And the wind will shift. And so my advice to most people in geospatial, because they often come at me and they come at me hard, is I say, don't spend your energy fighting it, right? Try to spend your energy thinking out how to embrace it and move it forward, and to differentiate what you do that you think is really special that will never be done with a phone, right? And I think if the energy's put that way, you won't get exhausted going against the wind. And when the wind turns, you'll be ready to enjoy the tailwind.
Yeah, absolutely. I think that's such a strong point to it. I mean, to what all of you are saying, there's a unique tool for every job, and mitigating risk and understanding what the right tool is for that job, that's important. And this is a new concept, in a way, a new solution with the lower tier, easy adoptable, easy to learn, low cost technology, how it brings huge, tremendous value in ways that are not being used. And that doesn't exclude the higher cost, higher time investment, higher training, higher accuracy and precision instruments that are absolutely necessary, in so many applications. They're not at odds with one another. They're tools, like any sort of tool. You might be able to, hang pictures with a little, home Black & Decker toolkit, but you're never going to take that out onto a job site if you're building a home, and you're not going to use the same safety precautions with one job versus another because the needs are different. The accessibility, being there on time, being there when you have to be there, how much accuracy is needed. Nobody's going to use like one of the high metrology scanners to do everything that they're going to do. It's not worth the time. It's not worth the investment for people to do. And this is the side where these are solutions that are being done, that all of you gentlemen are doing in real today, and saving people money, providing value, and helping to increase that adoption of tools as well, which, it's fantastic. That's why we're all so excited about the technology in so many ways. The as it improves, the adoption is increasing, the use cases are increasing. So it's wonderful. It's great. There's another question or two that came in, but we'll answer those after we're a little bit here over time. So we'll wrap up now. And Eugene, Nathan, David, thank you all for joining. This has been fantastic.
Yeah, thank you.
Thank you,
Been
James.
fun.
Thank you very
All
much.
right. Thank you, everyone.